Imagine the magic happening behind the screen of your phone. Each tap, each swipe, each notification, seamlessly flowing through a complex processes, systems, and algorithms, all working together to make your experience effortless. But behind all of this, there is a language, a silent architect that powers everything. A language called C. Respected course teacher, lecturer Priom Sir, and my dear classmates, a very good morning to all of you. Today, I have the privilege of introducing to you the language that has quietly shaped the digital landscape, C programming. Though it may appear simple, C is the very backbone of the technology we rely on daily. From the apps that fill our skins to complex systems running in the background, C is the unsung hero that makes it all possible. Beyond its simplicity, C is the tool of creation. It enables us to build, secure, and innovate. Whether it is managing data, performing calculations, or designing the future, C opens the door to endless possibilities. So let us journey into the world of C programming and discover how it continues to shape the future, one line of code at a time. Let us begin.
Yeah.
Well, let me introduce to our team members, and you can see all of their names. And now we're going to talk about what is there to talk about in our presentation. First of all, we're going to talk about the development, uses, and a little bit of history of C programming. Then we're going to see the basic structure of C programming, talk about comments that we use in the C programming. Then we're going to see another C program about adding two integers and also its uses, and we're going to also see all the arithmetic operations that could be done using C. After that, we're going to talk about secure C programming. This is basically the international guideline that we follow for writing code. We're going to talk about memory concept, about variables, its types, and also its location that it is stored in, and much more than that. Finally, we're going to talk about some decision making, about equality, rational operators. We're going to talk about if-else clause that we use in the programming languages. And overall, we're going to talk about the practical use of all of these things in the real life. Now let's go back to the history a little bit. It was developed in the 70s in the Bell Labs by Dennis Ritchie. It is a very high performance language, and it can also work in all the operating systems like Android, Linux, Windows, and all of this. So it is very compatible. And also C is very widely used in operating systems. Still today, it is very widely used. This is the basic structure of a C program we can see over here. And I have also added some comments. These lines do not run at all. These are not codes, okay? So we just give them to get a better understanding of the code. And this is the output you can see. Probably it will be very difficult to understand in the first place, so we're going to explain line by line about what is going on over here. Now, first of all, this hashtag include stdio.h. This is basically called a preprocessor directive. What do we do with this? First of all, this basically enables us to do input and output in the program. First of all, std means standard and IO means input and output. Using this, we can use different functions, for example, scanf, printf, putf, getf, and all of these things. Using this, we can do all of these functions. For example, we have used printf over here. We have printed the text hello world, and we can only use this because of this stdio.h header file or preprocessor directive. And then the main function. The main function is basically the core part of all the programming languages. Whenever you use any kind of language, all the functions you're going to use, you're going to put them in the main function. You're not going to be calling any functions outside the main function. And you can see the data type of the function. First of all, we have written int, and the int is basically the data type, so we have returned 0 after the end of our programs.
Integer.
Now, what will be the real life use of this Hello World program? Let's see. In case of microcontrollers, for example, Raspberry Pi, Arduino Uno, Arduino Nano, and other microcontrollers that is available, we use this Hello World program or any kind of program like this to confirm that the hardware is communicating with our command. In case of CI/CD pipelines, whenever we are going to try to build any huge applications, in that case, this kind of program might see, we can just see if our process is functioning, if our hardware is working. Also, in case of early stage of developing an operating system, when you develop any operating system, program like Hello World and this kind of program, maybe something else, we could print any other message to see if our operating system is booting or not, or our bootloader is working or not. And thus, using hello world program, we can also check if our standard input and output function is working. If our standard input and output is not working, then there will be some problems. After that, we will see another C program where we basically add two integers and figure out its sum. But to understand this program, we need to know a little bit more, because we have used some things. For example, we have used variables over here. So variable has few parts. For example, first of all, we have its data type we have introduced here, integer. We have also given it a name, that is result, and put a data. And we also have another thing in this variable which we cannot see, that is the location in the memory where the variable is situated. Here you can see, for example, in the variable integer 1, its location is 0x1004. So this is basically the location of the variable it is stored in. Then we took integer 2 and they added them and put them in another variable in another location, that is 0x11a2. So these are basically the locations in the memory where we have stored our data. So what would be the practical use of this function? We can use it for different purposes. For example, in case of addition of some prices, salary calculation, distance tracker app, student's mark calculator, and much more than that. Let's go through one by one. First of all, in case of addition of two prices, we can also do for more. For example, you are purchasing in a super mall. In the super mall, you will have the conveyor belt where you will put all the goods you have brought, and their prices will add up and you will get a final bill. And this kind of program would be working behind the scene, where they're going to take all the values and figure out their total. We can also use it for salary calculation system, where, for example, someone might have basic allowance and bonuses for their salary. We can add them up and figure out the total salary using this program. We can also have a distance tracker app. For example, how much I have walked for entire week. We can take input of all of those data and figure out its sum. We can also work with student mark calculator. Not only sum, we can also divide and do all of those things. We can get the total marks, average. And the programs we have, for example, we use Excel or any kind of database software, where in the background there might be programs like this to calculate the total. Now let's move on to the equality and rational operators. These operators are basically used in the if or else if part. In the if part, we have this condition part, where we're going to put a condition. If it is true, then the code written between if and else would run. If it is false, then the else code will run. So we have some equality operators: equals, not equals, greater than or equal, less than equal, and more. So you can all see all of those in this chart. Now, this code can be used for decision making. For example, we have written this code. For example, we enter two integers and see what is the relationship behind it. For example, here we have put 5 and 3. 5 is not equal to 3, that's true. 5 is greater than 3, that's also true. 5 is greater than or equal to 3, that is also true. So only the true terms return, and the false, they never came as output. Now let's see the real life application of these programs. First of all, we can make a smart traffic light system, home heating system, and fitness tracker goal progress. Now let's see one by one. First of all, in the smart traffic light system, we can check how many cars are there. If there are more than 10 cars, we can keep the green light on for a little bit more. If there are less, then we can maybe do it for a little bit less. So we can use this program to basically make a smart traffic light system that will adjust automatically. We can work with home heating system that will check the temperature. For example, suppose like 20 of my friends came in the room, then the temperature would rise. In that case, we need to turn on the AC. Otherwise, we need to turn off the AC, turn on the heater. So we can do both of those using this kind of home heating system program. And the program written behind would be like this. We can make a fitness tracker goal progress that would basically check what is the count of steps we have walked or ran. For example, here you can see if you ran more than 7,000, it would say good job, keep going. So it would basically inspire you to complete your goal. If it is greater than 10,000 or equal, then it would congratulate you because you have completed your target. So we can basically do that too. Finally, we're going to talk about some international standard that is followed, which are called CERT, C Secure Coding Standard. For example, first of all, Avoiding printf in case of string is a very good practice. Rather, we can use puts, because why use \n, that is the escape sequence, all the time? You have to use it every time you write a printf. So using puts is a much better option because it will just put you on the next line automatically. We cannot use keywords like auto, int, struct as the name of the variables because they are reserved. We can also format string, for example, make beautiful business timeline infographics. We can also work with secure input and output because scanf is not that secure. We can use scanf like _s or printf _s. These are basically more better alternative than scanf and printf. So these are basically the secure programming standard we follow internationally for writing better C program. And using C program, this is just the beginning. We can do a lot of things using C program. From making a video game to making an operating system, we can do all of that. So this is just the beginning of our C program part. And I would like to end with the quote: programming isn't about what you know, it is about what you can figure out. Thank you.
Yeah.
এখন দেখি
It's correct.
স্টপ করে